The periodic table has changed a lot over the last 111 years, and I have an interesting way of tracking those changes. Your response might be to point out the fact that the periodic table is significantly more than 111 years old. So why only track these changes back to 1913? As it happens, my interesting way of tracking only goes back 111 years. Fortunately, this is still significantly more than half of the 155-year current age of the periodic table. Now, this interesting way consists of these, a near-complete collection of chemistry and physics handbook editions. For our purposes, I'm missing only 4. The latest edition I'm missing is the 24th edition. I have no idea why that is so hard to get. And then the other 3 are the 2nd through the 4th, which would go in between these. Of course, my first edition here is actually just a facsimile that was handed out as a novelty with the 85th edition to show the size increase over the years. But that's okay, we only care about the information contained, so it doesn't matter that it's not original. If you only consider originals, though, I am missing a total of 5, because all my others are original. For those of you who don't know, the Handbook of Chemistry and Physics is a single-volume general chemistry and physics reference book that has been updated almost every year in the form of a new edition since 1913. Among other things, it has integral tables, particle physics tables, chemical compound tables, and, of course, the periodic table. This makes it an interesting way to track historical changes across chemistry and physics ever since 1913. Going all the way back to the 45th edition, there's a periodic table inside the front cover. In the earlier editions, it was presented differently. We'll see that when we get that far back in time. The current edition for 2023 and 2024 is actually the 104th edition, despite the fact that it's been going for 111 years. This originates from the fact that they skipped some years before the 45th edition, usually in association with something significant happening in the world, in particular World War II. The 104th edition periodic table is nothing surprising. Every element from 1 through 118 is both listed and named. We can see a few interesting details. The Handbook of Chemistry and Physics has chosen not to classify the state at room temperature of tennessine and oganesson, which is valid. No one's ever observed more than single atoms of them. However, they are classifying all of these elements as metallic solids, despite the fact that that isn't conclusively known. In fact, with all these elements past hassium, it hasn't even been experimentally confirmed whether or not they actually do fit chemically within their given group. It's likely, it certainly holds with hassium, but it's not certain. There have been chemical experiments with copernicium, but as I understand it, it's not uncontroversial. It's still considered somewhat ambiguous whether or not copernicium goes in group 12, although sometimes you will see that listed. So exactly why they thought it was certain enough to label these yellow, but not certain enough to give a label for these two, I'm not sure. Maybe it's the fact that all these elements are metals, and so they're presuming that these will be metals, although copernicium may not be a solid. Whereas over here we're on this metalloid cusp, and also the cusp of where elements start to become gases, so it's not so certain exactly what those would be. Certainly, if you were guessing, you could argue that these would be better guesses than saying anything about tennessine and oganesson. I suppose that's probably what it was. In the 2022-2023 edition, we have exactly the same periodic table as we had in the 104th. The 2021-2022 edition also has exactly that same periodic table. We haven't run into a change yet. The 2020-2021 edition has one of my favorite color schemes of any of them. However, the periodic table is still too recent to exhibit any differences. Just to be clear, I did actually buy this book legally after it was sold off so the library could replace it with the 101st edition. I did not steal it. Anyway, in the 2019-2020 edition, the 100th edition, although not the 100th anniversary given those skipped years, we have, again, exactly the same periodic table. Let's keep going. The 2018-2019 edition has my second favorite color scheme of any of them, but unfortunately it yet again has exactly the same periodic table. Now for the 2017-2018 edition. And once again, no changes. Still just up to oganesson, and no changes in their estimation of what the heavy element states are. It has occurred to me that there's some chance that there might be like a change in the known oxidation states of some of the elements in here, but I kind of doubt that because there are some really rare oxidation states, of some of these elements that are already not listed, so if they discovered a new exotic one, they probably wouldn't add it. For example, gold can actually reach the +5 oxidation state, and silver can actually reach the +3 oxidation state, and copper can actually reach the +4 oxidation state. So I suspect that isn't a change, but I haven't comprehensively checked. Next up is the 2016-2017 edition. And at long last, we see our first set of changes. While all the same elements had some evidence for them, they hadn't yet named nihonium, moscovium, tennessine, or oganesson. This reflects the fact that IUPAC approved the element names of 113, 115, 117, and 118 all together on November 28, 2016, and by then the 2016-2017 edition had already been published, so it didn't show up until we got to the 98th edition, as we just saw. Next, the 2015-2016 edition. No changes from the last one. We still have the same elements claimed but unnamed. Now for the 2014-2015 edition. No change from the last one again. Now for the actual 100th anniversary edition. The actual 100-year anniversary occurred with the 94th edition, reflecting the fact that the total number of years they skipped before the 45th edition, after which they didn't skip any, was 6 years. The 94th is the 2013-2014 edition. Let's see what they knew about the periodic table then. And yet again the same thing as the last one, so we haven't quite gotten far enough back to see another change. Next up is the 2012-2013 edition. We have another change. While all 118 currently known elements had been claimed, 2 more hadn't been named yet. 116, which was still called ununhexium, and 114, which was still called ununquadium, hadn't yet been named fluorovium and livermorium. This reflects the fact that the name for 114 and 116 were accepted by IUPAC and IUPAP on May 30th, 2012. This book was published in June 2012, I think, but it was probably still too late to change the periodic table at that point. Next up is the 2011-2012 edition, and we can see there is a change. Not only is tennessine not named yet, it's not even claimed yet. Astatine is still listed as the heaviest group 17 element. Tennessine was discovered in 2010, so it could have shown up here, but it wasn't until 2011 that one of the decay products was synthesized directly, one that hadn't been seen other than in the decay of tennessine. And I suspect it was that partial confirmation of the original 2010 results that caused them to add tennessine to the next edition. Now for the 2010-2011 edition, no change from what we saw in the 2011-2012 edition. Next, the 2009-2010 edition. Now we see a lot of changes. Not only is tennessine missing like before, but oganesson, moscovium, and fluorovium are missing, and also copernicium hadn't been named yet. The current name and symbol for copernicium was officially adopted by IUPAC on February 19th, 2010, so it makes sense that it wouldn't be in this book. It predated that. Nihonium was first synthesized in 2003, but the independent verification process ended up taking quite a long time. I suspect that's why it didn't actually end up getting added until quite a long time after 2003. These books do track the history of the elements, but also they do track certain editor decisions on what counts as credible evidence and what doesn't, so it's sometimes difficult to tell exactly what caused what. Moscovium was also first synthesized in 2003, and oganesson first in 2002, and I understand them to be a similar story. Next up is the 2008-2009 edition. Looks to be the same as the next year's periodic table. Next we have the 2007-2008 edition, and again the same as the last one. Now the 2006-2007 edition, and yet again the same. At least this does make filming quicker. Now for the 2005-2006 edition, and once more no change. Now for the 2004-2005 edition, and we have our next change. Roentgenium hadn't been named yet. It was still called unununium. This systematic name for 111 makes sense because the name Roentgenium wasn't accepted by IUPAC until November 1st, 2004. On a side note, one interesting thing you can see is that between the 85th and the 86th edition, the face dimensions of the books got larger. Now for the 2003-2004 edition, and aside from the lack of coloration, we see one other change. Darmstadtium hadn't been named yet, or at least it hadn't been accepted. It was still listed as the systematic Ununilium. This isn't surprising because IUPAC first accepted the name Darmstadtium on August 16th, 2003, after this book was published. There were some other names suggested by other teams in other countries that were competing at this time to make element number 110, but credit for the discovery was given to the Darmstadt team, and they got to name the element, hence Darmstadtium eventually being adopted. Next up we have the 2002-2003 edition. Nothing's changed though, we still have Meitnerium named, and all the elements before that. Next up, the 2001-2002 edition. We can see that there is a change. Ununquadium and Ununhexium are no longer listed. Ununquadium was first synthesized in 1999 and Ununhexium in 2000, but again it took a few years for it to be accepted enough for it to be added to the Chemistry and Physics Handbook, so it's not quite in here yet, even though this was published in 2001. Now for the 2000-2001 edition, and there are no changes. The same elements that are currently known are missing, and the same ones that are currently named are still systematically named. We now finally enter the 1900s with the 1999-2000 edition, and once again we have no changes. Now we get to the edition of my birth year, the 1998-1999 edition. I believe this was published in June 1998, and I was born in July 1998. And once again, unless I'm missing something somehow, there are no changes. Next up, we have the 1997-1998 edition, and we have quite a lot of changes. There's no longer a claim for 111 or 112, and a whole bunch of them hadn't been named. In fact, Lawrencium was the latest one that had an accepted name. Rutherfordium was still systematically named Unnilquadium, Dubnium, Unnilpentium, Seaborgium, Unnilhexium, Bohrium, Unnilseptium, Hassium, Unniloctium, Meitnerium, Unnilenium, and Darmstadtium, Ununilium. This is interesting. By still using all these systematic names here, it seems that they jumped right over the big naming controversy that happened between Russia and the United States, primarily for all of these elements. There were lots of competing claims and different contributions to the discovery of a given element by different teams, and who exactly got there first and who confirmed the other's results, whose data was the clearest, and all of that. It was kind of a mess. IUPAC issued several different naming suggestions, which got terribly negative responses, and eventually they settled on the familiar ones. You can see right here these first elements from 101 all the way through 107 were pretty controversial. The names changed a lot. Hassium was pretty uncontroversial. Meitnerium was, although there was one suggestion of Hanium there. Then Darmstadtium and Roentgenium were both pretty uncontroversial. We've already covered the naming of those, though. That's a later matter. And we haven't yet gotten to the point where, at least according to the Chemistry and Physics Handbook, the late actinides weren't sorted, although there was still some controversy surrounding nobelium. Lawrencium seems to have been mostly agreed upon, although early on there was a Rutherfordium suggestion, which ended up getting adopted for 104 in the later suggestions. Anyway, it's complicated enough. I'm not going to attempt to give some detailed history of the back and forth between all the different parties. The point is, the Chemistry and Physics Handbook seems to have skipped over most of this by just maintaining the systematic names until at least most of the controversy was over. Now for the 1996-1997 edition. And we have the same situation again. Up to 110 is claimed, still systematic all the way down to 104. But all the actinides are completed with the current names. Next up, we have the 1995-1996 edition, and still we have that same situation. Now we get to the only edition that I know of that ever came with a dust jacket, the 75th edition, also known as the 1994-1995 edition, and it does look pretty cool. I kind of wish more of them came with a dust jacket. I think this one did only as a celebration because of the 75th anniversary, but I'm not totally sure. Maybe they just decided to try it out this particular year. There is a noticeable change in the periodic table. We don't have Hassium, Meitnerium, or Darmstadtium even claimed anymore. However, Lawrencium was still named. Darmstadtium was first synthesized in 1994, Meitnerium in 1982, and Hassium in 1984. So Darmstadtium was accepted by the Handbook of Chemistry and Physics pretty quickly, but Hassium and Meitnerium were not. This probably just reflected the developing level of confidence in the given discoveries that the scientific community had. They do try to stick to that. And now for the 1993-1994 edition. And we have no new changes. Next up, we've got the 1992-1993 edition. And again, unless I'm missing something, no new changes. We have finally made it all the way back to the year of the collapse of the Soviet Union with the 1991-1992 edition. No new changes, still going up to 107, still named up to 103. Next we have the 1990-1991 edition. It turns out I actually remembered incorrectly at the beginning. The periodic tables don't show up on the inside cover in all editions, going all the way back to the 45th. In the 71st edition, the latest one where that appears not to happen, it shows up a few pages in, and we can see that it's still named up to 103 and claimed up to 107. And now we've finally made it all the way back to the 80s with the 1989-1990 edition. Wasn't Taylor Swift born in 1989? Or is that just an album name or something? I don't know much about pop culture. Ah, well maybe this is why I thought that it was in the inside cover all the way back to 45. I guess we'll see exactly how commonly it's not there, but certainly in the 70th edition, it's back on the inside cover, so it just skipped 71 so far. Maybe it'll be a rare occurrence. I'm suddenly doubting myself. Anyway, as far as the actual periodic table, it's still named up to 103 and claimed up to 107, so we haven't actually found a change yet from a little while ago. We've already seen the 75th edition. Now we're at the 75-year anniversary. Again, they're offset by 6 years. This is the 69th edition, also known as the 1988-1989 edition. And again, the periodic table is on the inside cover. Maybe that really is an anomaly and I'm mostly validated. Ooh, you see they've listed the noble gases here to reflect the way the electron configuration works. Downshifted one. I don't know how many of you have seen my YouTube video on arguing for a periodic table that includes that, the neutron, and double placement for both hydrogen and helium, but if you have, you'll know that I like this. Anyway, we still have no actual change with the periodic table itself. Lawrencium is still the heaviest one that's been named, and borium, or unnilseptium at the time, was still the heaviest one that had been claimed. Next up is the 1987-1988 edition. Again, right on the inside cover, and again, 103 is the heaviest named and 107 is the heaviest claimed. Now for the 1986-1987 edition, the year of Chernobyl. And yet again, still no change. We have now reached the year of Marty McFly with the 1985-1986 edition. And again, no change. Next up, we have the 1984-1985 edition. It looks like they didn't completely avoid all of that naming controversy after all, because here they did still call 105 Hanium. After this, it was switched back to unnilpentium, and then eventually to its current dubnium. It did have the Rutherfordium name, as it currently is, but the controversy did involve that one too. You can also see they dropped element number 107, so while borium was first synthesized in 1981, I suppose they weren't confident enough in it to add the claimed synthesis until a few years later. Another note is that they didn't include the systematic symbol in there as well. They did in the next one. Next we have the 1983-1984 edition. And it's the same as the next one, still listing Hanium, still only up to 106. Next up we have the 1982-1983 edition, and yet again, unchanged. On a side note, the 63rd edition is the first one that I ever got. It was given to me for free by a friend who thought I ought to have one. And a little while later I found it in my closet and thought that it was pretty great and decided to collect every edition I could, and you're now seeing the result of that. Next up we have the 1981-1982 edition, and again, no change. Here we are at the 1980-1981 edition, and also still no change. We have now reached the 70s, 1979-1980 edition. This is another celebration edition because it was their 60th, and the periodic table style has definitely changed, the text style. We can see that Lawrencium is, again, the heaviest one that has been named, and they hadn't put the Rutherfordium or Hennium names on yet, and they still only had claims up to 106. Next up is the 1978-1979 edition. Looking inside, we again see that Lawrencium is the heaviest one named, and it's claimed up to 106, but none of the names are currently recognized. I guess I wasn't paying close enough attention, but apparently they had observed the +4 oxidation state of element number 104 by this time. Now for the 1977-1978 edition, we can see we still have the same situation as far as the periodic table goes. However, we do have an interesting thing here. Apparently this particular book, which I bought off of eBay, was once given as an award to somebody. That's pretty cool. I wonder who that person was. Next up is the 1976-1977 edition. Ooh, another one where the periodic table isn't immediately inside the cover. The last time that happened was the 71st edition. Let's see if we can find it. It turns out it's on page B4, which is actually farther in, I think, than it was in the 71st edition. And again, it's unchanged. It is interesting to note that they've placed incorrectly lanthanum and actinium below scandium and yttrium instead of lutetium and lawrencium. I wasn't paying much attention because I was too busy tracking the changes in the known heavy elements to notice what other editions that appeared in. Now for the 1975-1976 edition. Okay, so the periodic table isn't buried far in the book this time, but it's also not quite on the inside cover either. And as far as the table itself goes, unchanged once again. Now the 1974-1975 edition. Okay, this is very interesting. We've got 104 listed down here, and then also right here, and then we have 105 right there. We also no longer have the +4 oxidation state claimed for element number 104. 106 is also no longer being claimed, which makes sense because seaborgium was first synthesized in 1974. It's actually a bit surprising to me how quickly 106 made it in here after it was discovered. Just in the next edition it was already in here. As we've been seeing, many of the later ones weren't added in until they had been claimed for quite a while. Next we have the 1973-1974 edition, and the same situation as the last one, no new changes. Next on the docket is 1972-1973, another one where the periodic table isn't in the immediate cover. It turns out it's actually on the inside of the back cover, and it's not different from the last one. So aside from the placement, there's nothing new. Next up we have the 1971-1972 edition, and again the periodic table is on the inside of the back cover instead of the front cover, and it has not changed except 104 is no longer listed at the end of the actinides here, which is kind of interesting. Next we have the 1970-1971 edition, yet again on the back cover, and here we have no more element number 105, and 104 is only listed at the end of the actinides here, and also the symbol for Lawrencium is listed as LW instead of LR. The first synthesis claim was in 1968 by Russia, but an American team also claimed to synthesize it in 1971, but that appears not to have caused it to have been added. It wasn't until 1970, specifically April 1970, that the Lawrence Berkeley National Laboratory announced the synthesis of it, and the Handbook of Chemistry and Physics appears to have only added it after that. I don't know if they didn't trust the Russian claim or if they were simply waiting for verification, just having two groups having done it. The first report of Rutherfordium was in 1964, so it doesn't surprise me that that's in here. It's still going to be a ways before that's dropped off. It was actually the Berkeley team that suggested the name Lawrencium and the symbol LW. The switch to LR was just something IUPAC chose to do, and I'm not sure why they did. Next up, we finally reached the 60s with the 1969-1970 edition. So this was the current edition when NASA first landed on the moon. That's pretty interesting. And there appears to be no changes from the last one, at least not that I can see. Next up is the 1968-1969 edition. Looking at the periodic table just inside the back cover here, I noticed two interesting changes. One, element number 104 is no longer claimed, and also the symbol for element number 103 is listed as LR instead of LW. This surprises me because the American team that named Lawrencium originally suggested LW, and then IUPAC changed it a little while later to LR. That's why you saw LW in the next few editions and then LR after that, but this is showing LR before that. I really don't know what the details are behind why that happened. The lack of element 104 showing up here or here, it makes some sense because the commonly cited discovery year for Rutherfordium is 1969. That's when the commonly accepted discovery was published. I did say the first report was in 1964, but given how commonly 1969 is cited, it apparently wasn't considered convincing on its own at least, and the Handbook of Chemistry and Physics editors appear to have gone along with that. Next up is the 1967-1968 edition. Now this is really interesting. We're back to LW for Lawrencium, and Nobelium is claimed but not named. The first complete and uncontroversial discovery of Nobelium came in 1966, so it makes sense that the discovery claim would show up here, although the name Nobelium actually originates from a since retracted discovery claim by Sweden and was simply retained as the element name because it had been used for so long. In fact, there was a fair bit of confusion in the early days before that incontrovertible Russian discovery. It makes some sense that the element symbol NO would only show up in this periodic table shortly after, namely the next edition, the first really incontrovertible detection of element number 102. Next up we have the 1966-1967 edition. Okay, they're still going with the symbol LW, and they're still citing that a relatively credible discovery claim for element number 102 has been made. We're now on to the 1965-1966 edition. Let's see what it's got to offer. So it's pretty clear by now that they didn't wait for that convincing Russian discovery to list 102 on the periodic table, but they seem to have waited quite a long time to list the symbol NO. This is really quite interesting. I'm not exactly sure at this point how they were making decisions. Now for the earliest large edition, the 1964-1965 edition. As far as I can tell, there's nothing different from the last one. Next up is the latest small edition. Inside this edition, I've found a very old-fashioned periodic table, one where they haven't actually separated out the transition metals from the main group elements. It's based off of dominant oxidation state, very liberally interpreted. Instead of group 1 just containing hydrogen and the alkali metals, it contains everything with a common +1 oxidation state like copper, silver, and gold. Similarly, group 2 doesn't just contain the alkaline earth metals. You can see zinc, cadmium, and mercury. Group 3 contains the standard group 3 of scandium and yttrium, but it also contains all of the rare earth elements rather than just lanthanum, as these books seem to be listing in a similar era. The carbon group here, or group 4, is containing not just group 14, but also the currently recognized group 4. So you've got carbon, silicon, titanium, germanium, zirconium, tin, hafnium, and then lead. Then over here we've got nitrogen, phosphorus, vanadium, and we also have niobium and tantalum here. These inclusions get a bit more and more ridiculous in my opinion as you go farther across, but still there is some sense to it. I understand the idea, and it is kind of cool. Chromium has a dominant +6 oxidation state because it also has 6 valence electrons. Molybdenum and tungsten shows up here along with the chalcogens. And then in the halogens, we've got manganese, technetium, and rhenium mixed in. So they didn't choose to mix the transition metals beyond the ones with a dominant +7 oxidation state into any more groups. It would be really ridiculous to put group 8 in with the noble gases of group 18. That'd be too much of a stretch. I don't remember if it was known at this point that, I don't think it was known that xenon even could form compounds, let alone a +8 oxidation state, lending the one bit of credence that that idea could have. Then cobalt, rhodium, iridium, there is no group 19, and nickel, palladium, platinum, there is no group 20 you could possibly mix that in with, and nothing attains an oxidation state remotely that high anyway. Then the noble gases, again, have nothing mixed in: helium, neon, argon, krypton, xenon, and radon. It still references the old name of emanation for that element because it was discovered as a gaseous decay product. Then it's listing all the rare earth elements here, which it referenced as being placed in group 3. That's pretty interesting. It doesn't seem to clearly place the rest of these actinides here, and it only lists up to mendelevium. If we flip over this periodic table, we get something much more recognizable, not nearly so old-fashioned. The transition metals aren't mixed in with the main group elements. None of them are. And this series here, the lanthanides and actinides, aren't all inserted into group 3 like the lanthanides were in that more old-fashioned table. And we see that NO shows up here. So it's almost like the Handbook of Chemistry and Physics believed the early discoveries enough to add 102 and the Swedish NO symbol, but then they lost some degree of confidence and at least took the symbol away and then re-added it back shortly after the really conclusive discovery was made. I don't know if that triggered it exactly, because it is the case that they did retain 102 throughout all of this, so they recognized apparently some credibility to the discoveries that existed, and NO wasn't even the Russian suggestion for the name anyway. What may have happened is they did take away the symbol due to reduced confidence in at least the early Swedish discovery, and then once confidence in the existence of this element was ensured by the Russian team, they decided to add the full name of the element back and only went with a Swedish name at that point because it was so heavily in use, which was what IUPAC cited later on when they finally made their last ruling on this. But I don't have a way of checking the editor's decisions, so that's just the best guess I have. Next up is the 1961-1962 edition. Again, we see a very similar old-fashioned table here, and this is the rest of that old-fashioned table. Again, it only goes up to mendelevium. If we move on to the more modern table, we see that, again, we've got 102 and NO for nobelium, but now we don't have 103 listed at all. I suppose that's consistent with the early 1961 accepted discovery date of Lawrencium. Next up, we have the 1960-1961 edition. On an interesting side note, mine still comes with the gold leaf you need to gold letter your name into the cover if you want to. So that's kind of fun. Yet again, we've got this really old-fashioned one, which continues just the same on the next page, and then we get over to the more modern one, which still stops at nobelium. It's the same as in the next edition, so we haven't yet gotten back far enough to see the next change. Next up is the 1959-1960 edition. Yet again, we've got the same old-style table. It has wolfram listed as a secondary name for tungsten. I can't remember whether or not the ones we just looked at had that, though I showed the picture so you can see. And here we've got the rest of that table, again, ending with mendelevium. The more modern table hasn't changed from the next edition yet either. And the only change on this more modern table that I'm noticing is the symbol A for argon instead of AR. I'm only noticing it now. Every time I notice, I feel like I need to go back and see if I missed it before, but I can't have filming this video take forever, so you can just look back and see whether or not this is the first appearance of A for argon, or if I'm only just noticing it now. Next up is the 1958-1959 edition. We are now solidly into the late 50s. Let's see what it's got for us. We have the expected old-fashioned table, and that's the same end of it, still ending with mendelevium. With the more modern table, we've still got A for argon and no new elements claimed or named. Next up is the 1957-1958 edition. I'm not noticing any changes here or here. I am noticing a change here. We've no longer got nobelium listed, neither claimed nor named. Let's see, the Swedish team first claimed discovery of nobelium in 1957, apparently, and the American team did in 1958. This, as I said earlier, is the 1957-1958 edition, so it would appear that they waited to list it until after the American claim. The really conclusive Soviet work came a bit later. Next up, we've got the 1956-1957 edition. Let's see, the only thing that I am seeing show up on this part of the old periodic table that's different from what I saw in the last ones is that columbium is showing up as an alternative name for niobium. There was controversy surrounding that. I believe also controversy surrounding tungsten versus wolfram. Oh, hang on a minute. I just noticed another difference. It used to be that tungsten was the main name and wolfram was the secondary name. But now wolfram is the primary name and tungsten, which we use today, is listed as the secondary name. That's super interesting. I wonder if I missed it in a few of the later ones. Let's see, what have we got here? I'm not noticing any changes. Oh, wait, hang on. They're not listing the actinides here anymore. That is another change. Oh, hang on a minute. What am I missing? They actually are listing the actinides. Let's go back over here. Okay, so now I'm seeing it. They're not listing it as a separate actinide series. They're recognizing the pseudo-transition metal behavior that they have. Thorium is in group 4, protactinium in group 5, uranium in group 6, neptunium in group 7. While the more modern periodic table in this same book has a separate actinide series, this older periodic table still reflects a lack of an actinide series, a separately recognized actinide series. Okay, so that's an interesting change. I'm not seeing any other changes, but it seems like it's really easy for me to miss them. I almost missed some of those. Now this is interesting. This periodic table doesn't contain einsteinium, fermium, or mendelevium, so there are 3 missing. They were discovered in 1952, 1953, and 1955, respectively. And this book is from 1956 and 1957, so I guess they decided that those... hang on a minute. You know what I bet it was? At least with einsteinium and fermium. That was during the time where they were developing the thermonuclear bombs. They were discovered from nuclear fallout, so that was kept secret. So that's probably why they weren't included until significantly later. Mendelevium was discovered in 1955, so the fact that it would only be added in the next one makes sense because this is the 1956-1957 edition. It does seem pretty common for it to take a year or two before it's added in rather than being added in right away. Although later we did see a few cases, if I remember correctly, where just the number was added in and then the name was added in sometime later, oftentimes much later. So that's pretty cool. We're seeing a bit of hydrogen bomb secrecy right there. We're really seeing a bit of history in these periodic tables. Next up is the 1955-1956 edition. I can't remember when in 1955 Marty McFly went back to, but if it was late enough in the year, this may have been the edition of the Chemistry and Physics Handbook that 1955 Doc Brown would have had. Okay, I'm not noticing any changes on this part of the table relative to the next edition. Let's see, this table only goes up to curium. I can't remember what the old format table in the next edition goes up to. Can't remember if it's farther or not. Doesn't always go up as far as the more modern table on the next page, but we'll see soon enough. Okay, yeah, this table does go farther, all the way up to Californium, so I don't see any changes on this more modern table. Next up is the 1954-1955 edition. Doc Brown would have at least had this on the bookshelf when Marty McFly showed up. The old-fashioned table is still looking the same on this page. The rest of it also still looks the same, just goes up to Curium. And this table again is unchanged, going up just to Californium. Next up is the 1953-1954 edition. No changes here that I've noticed anyway. And again, no changes there. Also no changes here. Guess we've got to keep looking to see the next discovery. Next we have the 1952-1953 edition. This is one of the thickest editions that I know of. There might be a somewhat thicker one, but this is at least close to as thick as they ever got. I'm not noticing any changes here, or here, or here. Let's keep going. Next is the 1951-1952 edition. All looking the same here, and unfortunately here too. Next we've got the 1950-1951 edition. I'm actually noticing a change. Instead of the secondary name for niobium being columbium, it's now germanium, which is interesting. I can't remember all the history here. I think it may have been one of those situations where there was competing discoveries and false discoveries and that kind of a thing. Anytime a thing is prestigious, it gets difficult. And then over here we see that element number 32 is called columbium. So that's interesting. I didn't remember that germanium used to have a different name that was at least accepted in the United States, these being American books. See if I can find any changes here. I'm not noticing anything. That was the big change there. Aha, they've switched to a periodic table that looks like this. I'm not sure I even properly understand this periodic table. Well, let's see. Nope, I see it. They've got hydrogen up top there. The alkali metals here. 87 doesn't have a symbol there. That's interesting. Neither does 85. Okay, so I'm not sure if that means at this point that they're not recognizing their existence. We have these recognized as transition metals. Thorium, I don't know if that's supposed... Oh, yep, that is an A. See, then the rare earths are listed down here. This is interesting. I can't tell. It looks like promethium doesn't have its current symbol. It also looks like samarium is SA. I'm trying to find technetium. There's molybdenum. Then it looks like manganese is listed twice. I don't understand what that's about. Polonium is definitely known. Radium is definitely known. Current symbol, all that. Radon, I can't tell if that's listed as RN. And hang on, the radium might be listed with RN. I can't tell. The print is... That looks like a solid RN, but I can't tell what that is. It's really interesting. Things are changing. This is getting exciting again. Another thing to note, this table doesn't appear to list anything heavier than uranium. This one still does list all the way up to curium. I forgot to mention that earlier. I was distracted by the other changes. Let's see, the discovery date of californium and berkelium are listed as 1950 and 1949 respectively, so they could have been in here. I can't remember if there were secrecy reasons why they didn't announce those discoveries. Yeah, I just don't remember the history in enough detail. Okay, I just looked it up. It appears like they weren't held back by secrecy. But I think that was the case again with curium and americium. We'll see when they drop out. At last, we enter the 1940s with the 1949 edition. I think they did the editions with 2 years listed because they were aligning those with school years, and they would sell the new editions to students and possibly to professors. If you go back far enough, however, you get years where they didn't do that. I do think they alternated a little bit, and we'll run into that. At least I think. I don't remember exactly. I can see they're only listing columbium there. They are listing the expected Rn and Ra atomic numbers there. They don't have francium listed. They don't have actinium listed. They don't have protactinium listed, and they don't have neptunium listed. They don't have polonium listed. It was discovered not that much later than radium, and certainly before 1949. That's confusing. Protactinium was also discovered in 1913, so I'm not sure why that's not in there. Francium in 1939, so that could be in there, but it isn't for some reason. Let's see, astatine. Let's see when that was discovered. Astatine was in 1940, so it could just as easily be in here. Okay, so Macerium, that was the name they're giving for what's now called technetium. There were many false discoveries of technetium, of people thinking they found it in nature, when in reality it's only present in extremely minute quantities in nature. The thing is, technetium was conclusively discovered in 1937, so I'm not entirely sure why this name technetium isn't here. There's a bunch of history that I just don't know. Let's see if we can find germanium and see what that's called. It appears germanium is back to being called germanium again. That's interesting. I'm not noticing anything else that's anomalous here. Oh, this is interesting. They're putting the noble gases on the left of the periodic table instead of the right. I had pushed in that video that I think I mentioned earlier for putting it in both the right, where it currently is, and the left, where this periodic table says it should be. With astatine, the atomic number isn't even listed, let alone a name. It was discovered in 1940. It could be in here. Polonium was discovered in 1898. Why is it not in here? Oh, wolfram is no longer listed as a secondary name. Well, this is interesting. This periodic table does list protactinium and actinium by name. It also lists polonium by name, but it does seem to be skipping 85 and 87. And it again lists manganese twice instead of... Nope, I was wrong when I said it listed manganese twice. This is that weird alternative name. I was just seeing a second N when that's actually an A. That was probably the case with the next edition too, where I said it's manganese twice. So that's an interesting clarification. This is getting interesting. I'm not used to the periodic table looking even this different, let alone as different as the one on the page before. This is pretty cool. Next up is a 1948 edition, which is listed 30th, but there are actually two 30ths, a nominal 30th and a revised 30th that came later. This sort of 1946, 1947, 1948 type era is one of the eras where they skipped some years without publishing a full new edition. This one, as you can see, is a revised 30th. We'll look at the nominal 30th next. The only new thing I'm noticing in this one is that the rare earth elements are listed below the table in kind of an interesting fashion. It doesn't really fit the groups. This is probably the case in the next one, although I didn't notice it because I was distracted by other details. Then at least at the moment, I'm not noticing any changes in this one either. Next, we've got a book from 1947. This is a nominal 30th edition. I'm not noticing anything different here. I'm also not noticing any changes on this table. It's complicated enough, though, that maybe there are ones that I'm missing. Anyone who wants to, I suppose, can look at it really closely. Next up is the 1945 edition. I'm not seeing any changes here. Yeah, again, maybe there are some, but I'm not noticing any. 61 is named Illinium. That was one of the false discoveries. That's pretty cool. I wonder if I missed this in the 30th and 30th revised. Again, there's so many little details here. Oh, here's another difference. Lutetium is spelled not like it is today. Yeah, there's so many little differences. It's hard for me to know for sure whether or not I missed things unless I wanted to go through a whole bunch of times, and I just do not have the time for that. And I don't think it matters too much because I am filming it and showing you, so you can spot any of that if you're interested. But yeah, one of the old invalid names for promethium. That's fun. You know what I just realized? This symbol right here at the 61 is IL, I think. That's probably for illinium. Just like this symbol MA is for that weird invalid name for technetium. So actually I remember seeing that in the promethium slot starting a ways back in this video. So it continued into several later editions, which means I did fail to notice it. That's pretty interesting. Next up is the 1944 edition. You know, promethium was properly discovered in 1945. So that means that they were still listing illinium in editions that actually came later than 1945. So that's interesting. It took them a while to accept the Currently accepted name of promethium. Can I find any other differences? Don't know what these markings were about. Still that name for that one. Not noticing any other differences. Still the same spelling for lutetium. Can I notice any differences here? Still SA for samarium. Still IL for illinium. So many symbols. So tiny. But yeah, I can't see any difference. Next up we have the 1943-1944 edition. It's interesting they switched back to aligning with the school years. As before, we still have the same invalid names for promethium and technetium, which we've seen in several later editions. We also still have that weird spelling of lutetium, and there's no number at all listed for astatine, and then just numbers for polonium, francium, actinium, protactinium, and neptunium. Perhaps this is actually like it was before, where there were some sort of claims, but there wasn't an agreed upon name yet. With the more modern periodic table, I'm not yet seeing any differences. Yes, nothing that I can tell. It still seems to be essentially the same as a number of later editions. Next up is the 1942-1943 edition. Still not noticing any differences on this table, or on this one either. I have been filming on multiple days now, so I can't say for sure that I'm not just forgetting something. Next up is the 1941-1942 edition. Okay, so I've just realized something that might count as a bit of an oversight. They also list descriptions of the elements, and the symbols in these lists actually go beyond what is present on the tables. I feel like I'm going to have to go back through some of these editions in order to figure out what it is that I've missed. For example, here, element number 85, which is just a number on the later tables, and also on this one, as we'll see in a minute, is actually listed in the element descriptions of this same book as alabamine, which is a name from a previous false discovery. Similarly, from the same false discoverer, if we look through here to the very end, we can find another nonsense name. Of course, they do list the promethium and technetium false names in both places. Exactly why the false names for francium and astatine aren't actually listed on the table, I don't know. I guess at some point or another I'm going to have to look through these books in more detail to really make sure I'm not missing stuff. They also have the accepted name for polonium listed here, and it's also just a number on the table, so this is interesting. I don't know what the details are on that. I feel a bit misled. Other parts of the book talk about more elements than are really clearly listed on the table. Oh, here we are, virginium. This is the false discovery of francium. And on this table, we of course see no references to those invalid names except promethium and technetium. No alabamine or virginium. In fact, we don't even have polonium. And then on this table, it's a similar story. They're the same table. I don't know why elsewhere in the book they listed those historical names but not on the actual tables. I'm going to go back into the later editions and see how far I can find references to alabamine and virginium. Back in the 26th edition, we still do have alabamine, so I was misled here. Let's see if virginium's there. It probably is. And there we go, there's virginium. Now let's go back to the 27th edition. Alabamine is here too. Kind of fun, they have a separate listing for deuterium, noting that it's actually just a form of hydrogen. They also have what appears to be some historical name for beryllium. Virginium's also here. Virginium and alabamine were only accepted for a few years, so I don't imagine I'll keep finding these for very long. In the 28th edition, alabamine is still here. Unsurprisingly, so is virginium. The 29th edition, which is the 1945 edition, if you remember correctly, alabamine is still in here, and doubtlessly so is virginium. Let's flip to it. And yep, there's virginium. This really does show how long it took for Margaret Perry's work on francium to be accepted. I think it was actually in 1937 that she did that work, and we're all the way in 1945 and it's still listed as virginium. If you look up the history, it did take quite a while. She had to meticulously defend her work for a long time before it was widely accepted. Alabamine is still here in the nominal 30th edition. Let's see, yep, Virginium as well. Okay, so here's some interesting information. An isotope mass 228-211 has been made by bombarding bismuth with high-energy alpha particles. Its general behavior is that... Okay, so this is the actual proper discovery of element number 85. And this is talking about Perry's discovery. So the story of how it records the changes to the periodic table is a good deal more complicated than I was originally expecting. The revised 30th edition still has that in there. I will at least try to get all the way to where they get rid of the name. And then, let's see. It's listing columbium as the name for niobium. Yep, Virginium with an asterisk still here too. 31st edition Alabamine still there, as well as Virginium. These names really hung on longer than I expected. I didn't realize how stubborn they were. Finally, in the 32nd edition, Alabamine is gone. Let's check out and see if they dropped Virginium as well. It is listing Promethium. I see the name Technetium finally showed up. And Virginium is also gone. So the 32nd edition was the first one that finally dropped that. Remember, I first was reminded that these were even in here when I was looking at the 25th edition. So that took a long time. With that tangent out of the way, we're going to move back to the main sequence and continue getting to earlier and earlier chemistry and physics handbooks. The 23rd edition is the next one I have, which is the 1939 edition. You may remember that the earliest one that I showed you before was the 25th. The 24th is one of 4 editions that I don't even have a facsimile of, and one of 5 editions that I don't have an original copy of, as I said at the beginning of this video. So going to the 23rd edition next is the best I can do. Alabamine did show up in the 23rd edition as well. I just noticed that historical name for radon here, niton. I've heard of that one. And of course, Virginium is there too. It's the same old-timey periodic table we've been seeing for a while now. I also am not seeing any changes on this table either. Next up is the 1937-1938 edition. This is actually the latest edition with the smallest face dimensions that this series ever had. From here on to the first edition, they all have the same face edition, they just get thinner. Alabamine was here too. There's Virginium. I'm excited to see how early I have to go for these no longer to be here. As far as I can tell, this is also unchanged, and so is this. Next up is the 1936-1937 edition. So this was published in the year of the famous Berlin Olympics. It's kind of interesting to think that this book is from that long ago. Same thing with the other ones that are from other particularly historic years. It's not just what science looked like back then, it's an actual science book from back then. Alabamine is still here, so is Virginium. These periodic tables also seem unchanged. Here's the first one. Here is the other one. Next up we have the 20th edition, which is also the 1935 edition. From now on, anytime the year isn't written on the outside cover, I'll just automatically show you the copyright date. To help make this as quick as possible, it's already getting so long. Alabamine is here too. So what was it, the 1949 edition that finally didn't have it? 1948 still did, at least with an asterisk. So now we're all the way back to the 1935 edition. They stuck with it for more than 10 years. I really didn't think these discoveries were accepted for more than a few years, but these books stuck with them for longer than that. And there's Virginium again. In the 20th edition, this periodic table appears earlier, and it doesn't seem changed as far as I can tell. I don't know how far back I'm going to have to go before I see another real change. And here is this table on the next page. I'm also not noticing any changes. Next up is the 19th edition, or the 1934 edition. Alabamine, Virginium, this table again, and this table again. Now for the 18th, or 1933 edition. This is probably the rarest edition I have. I've only ever seen pictures of one once, and they were from the eBay listing that I bought this from. I've never seen another one for sale. I've never seen evidence of one having been for sale. I'm sure it's happened, but it's rare enough that I've just seen this one singular instance of photos / a sale of it at all. Alabamine, Virginium, and we've seen this table now many times. There is one change in this book, though, and that is that this is the only table that's listed. The more modern-looking one isn't here. So that first happened in the 19th edition, apparently. Next up, we have the 1932 edition, also known as the 17th edition. Alabamine is not here, so that name first appeared in the 18th edition, or the 1933 edition. That's really interesting. Virginium is also missing. So they were present in these books from 1933 to roughly 1948. That's a long time. I was not expecting that. That's part of the reason why I wasn't looking too carefully. And here we are. I'm still not noticing any differences. Still remains to be seen how far I have to go back before there is an actual change. But the most interesting thing to have happened in the last two is that the location of the periodic table moved significantly farther in. Next up is the 1931 edition, also known as the 16th edition, and again it appears to be the same. Next up is the 1930 edition, also known as the 15th edition. See, I do see one change. Every time I notice a change, I wonder if I haven't missed it in the previous case. Element number 43 is now just listed as number 43 instead of as that weird, now defunct name, which predated technetium. This name for promethium is still there, though. Next up is the 1929 edition, also called the 14th edition. This is from the year that the stock market crashed, starting the Great Depression. Or at least at the beginning of the Great Depression. I am at least not noticing any changes. Maybe you'll see. Oh, wait, hafnium down here has not been placed. I'm just noting that now, and it's also given a secondary name of celtium or something. I don't remember. Let's find rhenium. Maybe I've been missing changes with that too. Oh, rhenium's down there as well. Hang on a minute, and so is this old name for technetium. Did I miss something in the next edition? Because I don't remember seeing that. Yes, I did miss it. This is the 15th edition again. And there's that hafnium and rhenium, and then mesurium, or whatever it was. This is the 16th edition again, and I don't see those changes, so it looks like I only missed it in one, the 15th edition, and I caught it in the 14th edition. So, not paying perfect attention, but at least it didn't slip past me for too long. Next up is the 1928 edition, also known as the 13th edition. Let's see, I'm still seeing these names down here, rhenium and hafnium. And then mesurium, I'm no longer seeing illinium, so that's interesting. I'm going to check real quick to see if I didn't miss that in the 14th edition. Nope, I didn't. Illinium is there, here in the 14th edition. Next up is the 12th edition, also known as the 1927 edition. Interestingly, it's spelled with an F. I'm not noticing any differences here. Maybe you see something that I don't and that I'll notice when I look at earlier editions. Oh, there's a number 61 there. I don't remember if they had that in the 13th edition. I'm going to check. They did. I'm going to check quickly to see if number 61 was listed in the 14th in that same spot. It is not present in the 14th because illinium is listed down there. So I guess that's my answer as far as that goes. Next up is the 11th edition, also known as the 1926 edition. Again, the same table shows up again in this one. At this point, if you look at the history of these elements, I'm really only expecting rhenium and hafnium to drop off, and maybe mesurium. If I remember correctly, actinium, radium, polonium, radon, all that. I think protactinium as well, although I'll have to check that, are discovered before these books started. I guess the other thing I'm looking for is any changes in the shape of the periodic table, i.e. how the elements are laid out in it. Next up we have the 10th edition. At least this copy was printed in 1924. Now it has occurred to me just now that they may have been printed in the second half of one year and the first half of the next year, and so I shouldn't probably call it the 1924 edition, kind of like I've been doing with some of the later ones, because it very well was also printed in part of 1925. Now this is interesting. This periodic table almost looks slightly closer to what I'm used to. And there are lots of differences between it and the one in the next edition. First of all, we see this glucinum for beryllium listed with the symbol Gi, where beryllium is just a secondary name. I think that's the first time that's happened. Also, ytterbium seems to have a secondary name, and niton is the accepted name for radon. That's super interesting. The 10th edition here also appears to be the latest edition that doesn't list rhenium and hafnium, so I finally found the edition that doesn't show the last two stable elements ever discovered. This being printed in 1924 fits that pretty well, given when they were discovered. Of course, it didn't happen all at once. There were the initial reports, and then really pure samples didn't get produced until later. However, 1924 is about roughly the right time for this to still be missing them, and for the next one to have them. Yeah, a bunch of these elements that were excluded and put down here, like thulium, for example, are still up in the table, but not in a lanthanide series. So man, this is getting really old. Next up, I have a 9th edition, which was apparently printed in 1922. The early Roaring Twenties. Here is its periodic table. It's looking the same to me as the one in the 10th edition. Let me know in the comments if you see any differences. Next up is the 1920-1921 edition, also called the 8th edition, so the first one solidly in the 20s. I'm not noticing any changes between the 8th and the 9th. Hopefully this is a good enough view of the table that you can spot any that I might be missing. Next up is the 7th edition from 1919. We're now before the 20s. This is really cool. And actually, with at least the 8th edition, we're past 100 years. These books are officially antiques. And here we have what appears to be an unchanged periodic table again. At this point, I'm not sure whether or not we'll still see any changes, but of course, there's only one way to find out. Next up is the 6th edition, my copy having been printed in 1918. It's also all looking pretty much the same. On to the 5th edition. My 5th edition copy was printed in 1916. It's the oldest book I own, and this one is also looking pretty much the same. Well, the 5th there is the oldest original edition I own. I do have a facsimile of the first, as I mentioned. It was given out with the 85th, so we'll take a look at that to see what kind of periodic table the very first one had in it. And here we are. It does look about the same as the one in the 5th edition. I'm not noticing any differences, so I suppose if you want periodic history that goes back farther than 1913, you gotta look elsewhere. But still, this is quite a bit of history that these show, and since these are actual historical books, original copies in the case of everyone but this one, it really does show you how people arranged it for practical use at those times. It's authentic. The thing that really surprised me the most about those periodic tables is their handling of elements protactinium and actinium. To some extent also francium and astatine. They did call francium and astatine virginium and alabamine respectively, as you saw at length, but they didn't stick them in the table, they just put them in by number. I don't know what the reason was for that. And even though many of these tables were definitely after the discovery of protactinium and especially actinium, they didn't seem to really show up until much later. I don't know if they just didn't know where to place them because not enough chemistry with those elements had been done yet. Broadly speaking, I was surprised at how complicated the history was, at least as told by these periodic tables and the glances we looked at the element descriptions that these books also tend to include. In particular, it gets complicated when you compare them to the accepted list of discovery dates. Exactly what names showed up when and in which places within the book was not precisely aligned with those discovery dates. It makes science history seem messier than I tend to imagine it. Anyway, I hope this video is interesting. Thanks for watching. Okay, so I'm here with something of a postscript regarding the editions of the Chemistry and Physics Handbook that I haven't managed to obtain. A while ago, I saw this picture on Facebook from 2014 when the 95th edition was first publishing, and it revealed to me that some of the early editions that I don't have are actually held in the library of CRC Press. And I know they aren't super expensive collector books. That's one of the reasons why I'm able to get into them. And so I figured I would email them once I'd gotten all the editions that I could get, which I've since done, and ask them if they had any that they'd be willing to part with. Specifically, I sent this email via their website. My hope was that they'd be motivated to do this by the fact that I had shown such interest and dedication to getting everyone so far, and that they might find it kind of cool to help me complete my collection. I even attached a picture of the stacks of books that you saw in this video on my desk and next to it. But of course, they did not do that. In fact, it sounded like they didn't even really understand what it was that I was asking for. I was asking for kind of an unusual exception. And so to clarify, I sent this email. They then gave me this disappointing reply here, and that's where I left it. So worth a try, I guess, but no cigars.